All right, some LT5, constructing dot plots, histograms, and box plots for data on a real number line. We're actually going to change this. We don't really care that much that you can construct them. We're a lot more interested in your interpretation. So change that to say interpret dot plots, histograms, and box plots for data on a real number line. The first one that we're going to look at is a dot plot. And so here's our data set here. And the variable that we are looking at, or the thing we're measuring, is the pulse rate in beats per minute. So a whole bunch of people got their pulse taken, and here were the results. A dot plot shows each item of numerical data above a number line. Okay, so we've got one person with a BPM of 56. We've got two at 60. We've got one at 68. And then we've got two at 76 and one at 96. There are little notes in here that when you're creating this, and you guys know how to make a number line, but basically just like make sure that everything is scaled the same. The minimum is the furthest down. You don't need to make your line go any further down than that. Put a little title on it, and then there's your maximum there. But a dot plot basically just shows how many of each value there were. So obviously there were two people with a pulse rate of 60, two people with 76, one of 68. Pretty self-explanatory, I think. Histograms are not the same as a bar graph, and I'll go over that difference in just a minute. But sort of similar to a dot plot, data is shown by a bar instead of dots. Now it's shown by a bar, marking the count or frequency for each interval. Okay, and so for this example, we're looking at quality ratings of potato chips, and so it looks like there was one bag of potato chip with a quality rating from 0 to 5. Over here at from 35 to 40, there were 6 quality ratings from 35 to 40. There were 2 quality ratings from 45 to 50. And so what this shows you is just how many of each thing there were. Okay, and so you can see that for the most part of most of the chips that they tested the quality rating of, most fell in, I would say, this sort of 30 to 45 range. Okay, so most of the bags of chips that they tested at a quality rating from 30 to 45. And so that's what we can kind of see from this, is we can sort of make a generalization that most potato chips are quality rated 30 to 45. All right. The difference between a histogram and a bar graph, because you guys have seen like millions of bar graphs before, but the difference between a bar graph and a histogram is if you look down here, along the x-axis, we have categories in a bar graph, okay? And in a histogram, these would be numerical values. So like you see the quality ratings here for the histogram. For the bar graph, you see categories or months, okay? So that's the main difference there. A box plot sort of goes back to last video, because basically once you know a 5-number summary, you can quite easily construct a box plot. And so what a box plot shows you is are all the pieces of the 5-number summary. So right here we've got the minimum. Over here we've got the maximum. And then you've got this box here, okay, this box. The middle line of this box shows the median. The lower line of the box shows Q1. The upper line of the box shows the Q3, okay? And so how we can look at this then is, obviously we can tell points scored. I think this comes from the Chicago Bulls example from the LT4 video. The minimum points scored we can see right here, and we can kind of estimate it was about, between 1 and 200, maybe 150 or so. The median was slightly over 400. The maximum was up here. I think that was like 2,300 and something. And so we can easily see all those different things. This part of the box here, this middle part between the Q1 and the Q3, so the whole length of the box, that represents the IQR, the interquartile range, because it's the difference between the Q3 and the Q1. So this is really just a visual way of seeing a 5-number summary. And then again, you've got a number line under it. Just make sure that that's scaled accurately and consistently. So we can see the Q1, we can see the Q3, we can see the IQR. Another thing that a box plot kind of shows us is like the overall range of the data. And so in this one, our range, it goes from 150 or so all the way up to like 2,300 and something. And so we can see what our range is. And this little part here is called the whisker. This little line here, we've got the box here, and then we've got the whisker here. The longer that those whiskers are, really just tells you that there's a minimum way outside of everything, and there's a maximum way outside of everything. So that can really show you like a huge range in data. A really big box might also mean a pretty good range in data. A really small box, like if we had our box and whisker plot, and it looked like that, would mean we have a huge cluster of values right around the median. So there'd be lots and lots of data really close to that median, and then one huge outlier, one really small outlier. Okay? But this IQR is pretty small. And if you have a really small IQR, it means there was not a whole lot of variation in the data. So if we're looking at like points scored or something, this could be a team, like a very well-balanced team, minus like Mr. Ballhog up here, and like guy who sucks down here. So like you'd have this huge cluster of data right in the middle where like most people on the team are scoring very close to the same number of points, minus these two whiskers, the minimum and the maximum. Okay? So really looking at this and noticing different things about it and breaking it down and saying like, well, what does a small box mean? What does a big box mean? What does a huge maximum or minimum do to the data? Those kind of things are the more powerful connections that we're trying to get you guys to make. And so your before class gives you a box plot summarizing the final test scores for 2 of Ms. Werner's algebra classes. And so the question is, which class has a greater range of scores? Which class has the greater IQR? Which class did the greatest fraction of students score above 80 on the test? So we're looking to answer those 3 kind of interpretation questions based on these 2 box plots over here.